Okay, welcome to the second set of videos for this module. And what we're going to be doing today is we're going to be looking at a really basic skill that's super important. And by the time we get to the end of the semester, this kind of a thing is just going to be like secondhand for you. It's going to be like breathing. Okay. But it might seem a little strange now, but most of you are going to kind of go, oh, yeah, okay, that makes sense. I can do this. All right. Now, just one of the things you want to keep in mind is you, with your career and your goals, you need to be able to move from a place of, oh, yeah, well, that makes sense to this is as easy as breathing. Okay. So, in other words, proficiency. Okay. Proficiency and accuracy in your calculations. Okay. You need to be able to do them quickly and accurately. Okay. And together that's called proficiency. You don't have to think. You don't have to stop and think. This just needs to be second nature for you. Okay, so let's get into it here. We've got another eye bolt and we've got some ropes attached to it, and there's some tension acting on each rope. And so we have three different force vectors there, F1, F2, F3, and well, that's it, just three of them. Okay. So our job, it says resolve each force acting on the post into its X and Y components. Okay. So what we have is magnitude, and remember, a vector needs magnitude and direction. So we are going to try to figure out how do we express this in that way. So let's begin here with just something really generic and talk just a little bit about it. Whoops, that's the wrong thing there. Okay, so if we have any given force vector, okay, we can express that as some x component, I hat, plus some y component, j hat. Okay, just like that, whatever that is. And there's another way that we can express that, and that is with the bracket notation. And this is where we put fx, comma, fy. Okay, just like that. Now, it's important that you use the brackets. Don't use parentheses. A parentheses is a dot. That's a location, okay? We need a bracket here. So it's the x component, comma, the y component. If you're in three dimensions, like you'll be doing in Calc 3, you'd have xy, comma, fx, comma, fy, comma, fz, comma, all within brackets there for your different components. All right, so let me just show you one more thing here, and that is it's going to be very convenient to write this, that second one, as f onto some let's just for right now call it cosine sine, sort of like that. Some way that those things are split up. And what I want you to see right now is that this part right here has a magnitude of 1. And so if we can do this where we say the magnitude of the vector times something about its direction, okay? And in fact, this expression down here is what we call a unit vector in the direction of f, just like that. So not sure if you've gotten to unit vectors yet in Calc 3. If not, you'll get there pretty quickly. And that'll make a little more sense once you get there. All right, so let's dig into it. Let's just start with F1 here. And so F1, and I'm going to do all these in bracket notation because it's just a little quicker and easier to write down, and you get all the information that you need. So if we look at F1 as a vector, all right, we need F1x, comma, F1y. And looking at that vector, it runs right up the y-axis. So there is no x component. So the x component there is 0, all right? And the y component is all that there is. Everything's in the y direction, or we should say the j direction. So that becomes a 300, just like that. So there's my expression for F1 in Cartesian coordinates, okay, with its components that way. So 0, 300. Okay, let's take a look at the next one. Oops. Okay, so on this one, then we've got F2. Here we go. And what we're going to have here is we're going to need F2x and F2y. That's how we're going to write that. So we need the x component. So let's take a look at our drawing over here. And you can see if we make a little triangle on this vector right here, the base of this triangle right here, that's my x component, f sub x, which means f sub x is f cosine theta. So let me put that up here over here. I'm going to have f2 cosine theta. Now, theta happens to be 45 degrees. We'll stick that in just a second. Okay. We need to also take into account whether it's left or right. Okay. So the cosine theta alone doesn't necessarily help us unless we decide to get really try to be really technical and define theta from the positive x-axis. Then that'd be 135. Cosine of 135 would be negative. Either way, we need a negative sign right there, okay? So let's go get the y component for that. The y component is this side right here, okay? So we might want to put that over here if that makes you more comfortable. Okay, so we've got our x component there. We've got our y component here. There's F2y. But realize either way, no matter where you draw it, it's that height side of the triangle right there, which means it's opposite. It's the opposite side, so we use the sine of the angle. Ooh. So we're going to have F2 sine theta. All right. It's up, so that's positive. So we don't have to worry about that. Everything is good. Okay. So F2 then is going to become its magnitude at minus 450. Oops. Cosine of 45 degrees. And then we're going to have 450 sine of 45 degrees. We're going to put that in there like this. Okay. Now, once you run the numbers, what you're going to get here is you're going to get minus 318.2 and positive 318.2. Okay. There we go. Pretty straightforward. All right. We still have to do F3, but I wanted you to have a chance to kind of look at that real quick. Be careful with your calculator. All right. Number one mistake when it comes to dealing with angles in calculators, especially since almost all of you are in Calc 3. So in Calc 3, you're going to do a lot of stuff in radians mode. Okay. Right now, actually in this class, pretty much probably for the whole class, you're going to need to be in degree mode. Okay. So if you're putting some number into your homework and you're like, I did everything right and it's not coming out right, check that first. Okay, because that could be an easy fix for you. Be like, oh crap, I'm in radians mode. Fix it, recalculate, you're in business. Okay, that happens a lot. Don't let it drive you crazy. Just make sure you check that as one of your first options. Okay, so I am gonna see if I can make this stuff a little bit smaller. Kind of worked. Move it out of the way just a little bit. There we go. Now I'm going to switch colors for this last one. Okay, so F3. Now, I need to get rid of my arc. There we go. I don't need that triangle anymore. We'll just refresh the whole picture. There we go. Now, what I want you to notice, I want you to take a look. Oops. I want you to take a look at this triangle right here. Okay. Now that is a kind of notation that may be unique to engineering. I don't know, but it's probably something that you haven't seen before. And what they're doing with that little triangle is they're telling us directions. They're telling us directions. And with F2, the 450 Newton force, they give us 45 degrees from the negative x-axis. That's how we got direction. Here, the 345 tells us the direction. So 345 is kind of a perfect triplet in terms of triangles. We're going to see a few of these. Mostly we're going to see 345s. So 3 squared plus 4 squared gives you 9 plus 16, which is 25. Square root of 25 is 5. Okay, so it's a triangle with a right triangle with 3 whole numbers. It's kind of unique. There aren't a whole lot of those. Now, how it's useful to us, once you get the hang of this, you're really going to like it. Okay, so I'm going to redraw it because it's super tiny and on the picture, and I need you to be able to see a little more detail. All right, so it says, according to my triangle, I'm 3 here, 4 here, 5 here. Let's call this theta. Okay, so when we're doing our vector, we're going to have to get to sines and cosines. All right, so what a lot of people try to do right away before they get used to this is they try to go, oh, I have to figure out what theta is so that I can get the sine of that angle or the cosine of that angle. Okay, so they're going to be like, oh, okay, first thing I'm going to do now, don't do this. This is a waste of your time, but I'm going to show you. Don't do this. They're going to go, oh, tangent of theta is rise over the run. So that means theta is the inverse tangent of 4/3, blah, 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 blah. And it works out to be like 37 point something degrees. I don't remember what it is. You don't have to know what it is. It doesn't matter. Let me show you why. It doesn't matter because what we want is we want the sine of theta and the cosine of theta. We don't care what theta itself is. We want the sine of it or the cosine of it. Okay. And we know that sine is going to be opposite over adjacent. So the sine is 4/5. The cosine, well, I said that wrong. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So that's 3/5. Okay. So let's do this. Okay, so I know that if I want to get a good expression for F3, what I have to have is F3x, comma, F3y. But my F3x is going to be F3 cosine theta, and my F3y is going to be F3 sine theta. Okay. Then I can take this, dump it in here, and that, and dump it in right there. Okay. Like I said, I don't ever have to know what the value of theta is. So F3 happens to be 600. So we're looking at 600. Cosine of theta is 3/5. And then we're going to have 600. And then the sine of it is 4/5. Okay. Do your math. Okay. Get your skills built up in your head. Okay. Don't get overly dependent on your calculator. All right. You need to be able to kind of do some of this stuff in your head. So 600 divided by 5 is 120. How did I get that? so quickly? Well, it's 60 divided by 5 is 12. So that's where the 120 comes from. Just take it times 10. So I've got 120 times 3, which is 12 times 3 is 36, add an extra 0. So then we're looking at 360. And then 120 times 4 is going to be 480. Okay. Always at this point, pause. Say, is this up and down, left and right? Check it out. So it's to the right. So I've got a positive in here, and it is vertical. So my other number is also positive. And so I'm golden. I got it there. Okay.